Good afternoon, everyone, and welcome to our first ScholarSeries presentation, Artificial Intelligence Explained. It's going to be a good one. I'm Lena Barbieri with the Institutional Advancement Division, and we are delighted to introduce this series, highlighting the research and the work of DeSales University faculty, staff, and we'll even get some community members. Today, our guest will offer a presentation followed by a question and answer segment. So that's the setup of this program. So on to introducing our distinguished scholar. Dr. Brennan Pursell is a professor at DeSales University with a joint appointment in the divisions of business and humanities. He teaches courses in management, data analytics, applied AI, and even history in both the undergraduate and graduate programs. He is the founding and current director of the Applied AI program here at DeSales. His current book project, Outsmarting AI, Power, Profit, and Leadership in the Age of Machines. This book destroys myths that are widespread in artificial intelligence. He clarifies the technology's capabilities and limitations across sectors, and he shows how to implement it profitably, ethically, and in accordance with the law. Dr. Pursell was first trained as a historian, having earned his bachelor's at Stanford and his PhD at Harvard. He's published, I think it's 4, maybe more books and dozens of articles about topics in modern European history. And he shared his expertise and scholarship on CNN, EWTN, countless radio outlets, and in major US newspapers. He's a dedicated lifelong learner. He works on data analytics, coding, and AI skill development projects every single day. And he's managed to find time to complete his MBA at DeSales back in 2014. So this is quite a learned and busy gentleman. Ladies and gentlemen, please welcome Dr. Brennan Pursell.
Thank you for that introduction, Lena. Thank you very much. And welcome everybody to this session. For full disclosure, I'm sorry, I have to say this. I kind of threw out my back yesterday morning, so I'm locked in this chair, this one position that seems to work. I mean, and I'm assuming there's people in the audience that know what I'm talking about. You bend over and it's like, oh no. I'm doing okay. If you see me like wincing, it's not because of you, it's because of me. And so what we're gonna do is we're gonna launch right into this, and I'm gonna explain to you what artificial intelligence is, what it can do, what it can't do, and actually how it works, and all of about a half an hour. And then we'll have plenty of time for Q&A, right? You know, and we'll just have a good open conversation about that. So welcome everybody. Let me do screen share. Let me share the screen. Boom, we're sharing. Can everyone see the presentation? Can I get nods from the team? All right, there we go. So let's make sure this thing works. So this is our title. And let me move everyone here to the side. This is even better. Okay, artificial intelligence explained. There's so many myths about it, and you know, at the end of the day, it's just math. All right, let's click on this. Right, AI. I'm sure you've heard all about AI. It's been called the new electricity, the fourth industrial revolution, the second machine age. You know, there really is something to this, because when electricity came out, it didn't change everything overnight, but it took some time, and it has been changing pretty much everything. There isn't a single sector of the modern economy that doesn't use really electricity, okay? Fourth industrial revolution, we'll see how far AI can change industrial processes. Second machine age, fine. What they're talking about is that computers are dumb and they're getting smart. I will maintain computers are as dumb as they ever were. All right, there is major change, you can call it disruption, especially in the white collar businesses or sectors listed here, just through the use of AI technologies. You look for it, you see it everywhere. Sales, marketing, and advertising, especially through Google and Facebook, they've really been the trailblazers. Logistics and transportation, Amazon has been the trailblazers, but it's getting into fintech. Healthcare is a little tougher because of the regulatory landscape, and of course the nature, almost kind of mysterious aspect of health and medicine itself. Retail, brick and mortar is trying to stay away a bit, but you know, they're not doing so well in COVID times. Social services and government, if only they would use more of it, good heavens. We could talk about that. Legal services, please, for the love of God, please start using more chatbots. And in education, we need to train people. We need to educate people on what this is and train them how to use it so that they don't become part of the hundreds of millions or billions of people who are just used by it. We need to learn it and learn the tools and use it legally, ethically, and profitably. This is just a little advertisement for my book. Please pardon it. This is the QR code in the middle. Wrote it with co-author Joshua Walker, and Outsmarting AI. It was great fun, immensely challenging to write, and a little personal self-promotion. Okay, there's a lot of science fiction. Have you heard of this? Have you heard of the singularity? The singularity, I think, is this prediction that when AI kind of gets everywhere, we will move into new economic times in which the laws of economics will be rewritten and no one will be poor anymore and computers will solve all problems and it's going to be great and you won't even need to work because everything will be automated and it's going to be wonderful. I kind of doubt that's going to happen. Superintelligence, have you heard of superintelligence? When AI combines with the human brain, we will get a new kind of intelligence that will come up with even more great things. I mean, these are great utopian kind of visions. I think they're a little more emotional than rational. AGI, General Artificial Intelligence, that acronym doesn't match that. That's embarrassing. Or GAI, I've heard it both ways. General Artificial Intelligence or Artificial General Intelligence. Again, that's a combination of the brain and AI coming up with just something wonderful and fabulous. And there are people actually trying to engineer this. And there's a lot of money washing around Silicon Valley. And there are people chasing some of these projects. And then the Church of AI, a great piece of news just lately, what's his name? Anthony Lewandowski. This is the guy who helped Google to build Waymo, its self-driving car unit. And then he left Google and took his laptop and all of the information and data and algorithms with him to Uber. This is a flagrant violation of trade secret law and everything else. And he's been busted. He's multi-millionaire. He's now declared personal bankruptcy. This guy founded this creepy thing called the Church of AI and some other things where you're supposed to worship the AGI or superintelligence. Kind of embarrassing. Those things have recently bellied up, I'm glad to say. Anyway, here are 7 most common AI myths I would like to destroy in 2 minutes flat. Number 1, AI is not a robot. Robots should use AI, but robots are gizmos. They have actuators and power capacitors. They do different things. AI is not always a robot, okay? Do separate. Robots have been around for a long time. Before there was AI, and AI operates most successfully and profitably not in robots. AI knows what it's doing. It has no idea what it's doing. It has no consciousness. It has no self-awareness. It just doesn't know what it's doing. Even when it nails prediction, even when it nails image recognition, it doesn't know what it's doing. It's people that know what it's doing when it's messing up. AI is inescapable. Well, you may feel that it's inescapable because every time you use this, every time you use any device and you produce digital data, it is scraped off the internet and categorized by these internet monsters. And yeah, they kind of know every key strike about you, but you can just turn them off, You can turn them off. And no, you can go through life as a perfectly good human being without using AI. It is not inescapable, but man, it is suffusing the modern economy. AI has insight. This is kind of like AI knowing what it's doing. No, it doesn't. It really doesn't. AI analytics, like data mining analytics algorithms, yes, these things are really good at finding certain patterns, mathematical statistical correlations in digital data, but it does not have insight. It's people. People have insights based on some of the patterns that AI can find. AI means easy money. Well, it certainly does if you happen to own Google, like Larry Page and Sergey, I'm forgetting his last name, Sergey, it'll come back to me. Those guys, multi-billionaires. It's kind of crazy. However, it's the case that half of all AI projects fail because businesses across the country, management is facing pressure from boards saying, you got to do something with AI. We got to do something with AI. And they blow it. and GE pretty much went down in flames from pouring 8 billion into AI and getting absolutely nothing out of it. AI drives businesses? No, it doesn't. You do. People do. People lead organizations. AI does not. AI will control your mind. Okay, so Elon Musk, one of my favorites, he has this little company called Neuralink, and he's getting people to volunteer to drill holes in the back of their head to put in these little micro wires. And Elon Musk is the guy who promises things and never fulfills them. We heard like 3 years ago that a Tesla would drive from San Francisco to New York with nobody in it. Of course, it never happened. Nothing ever happens to him. Gonna go on Mars. Yeah, live on Mars. AI is not going to control your mind. Yeah, people are having wires put into your head, but he's saying we're going to upload memories. You won't have to go to school. We're going to upload all that information, and we'll be able to give you religious experiences, and you'll be able to like be everybody. No. Okay, 7 AI rules. This is key for making sure that AI works for you. And these are priorities. I'll just go through them quickly. It's really important to abide by the law in the country that you live in. I'm sorry, it just really is. We all have to live together, and law is just really important, especially in democratic capitalist countries like the United States. And acting ethically and stopping AI when it helps girls who cut themselves to get more content and more reinforcement that they should keep cutting themselves. Do we agree this is an unethical use of this? Yeah, how about we do that? How about, can we stop child pornography? This is the most vile thing ever. Can we agree this is bad? And anything we can do to stop is a good thing. All right. There's a lot going on in the AI world that would just shock you. It's just incredible. Data is the mother of AI. No data, no AI. Forget it. AI needs data. You can't buy it off the shelf. No. Math is the father of AI. You apply mathematics to digitize data, and then maybe you can get some artificial intelligence going. AI systems are like kids. They're all unique because the data is different. And you'll see this when I show you the inside workings of the algorithms. They're all a little different. My God, does AI need parenting, governance? This links up with number 1. Embrace the cyborg. I really believe this, not that we should wear AI and be AI, but the tools can really help, especially in the white collar professions, to augment human labor, to take the boring stuff, the repetitive stuff, and automate it so that we can really solve the problems that are nagging and do the things that only humans can do. And then platform. You can't do this unless you have a good platform that unifies the data, consolidates the data, breaks down the silos. For every organization taking this stuff seriously, platform is the key.
Dr. Pursell, we do have a couple questions. I just wanted to jump
Fire
in here.
away.
Okay, what is the difference between AI and algorithms? Are AI just algorithms?
Yes, an algorithm is a mathematical procedure. Artificial intelligence, it's been described as a zillion things. All it is a bunch of algorithms working on digitized data. Just data and numbers. That's what computers do. They do math. That's all they do. That's it. But you put their capabilities together, and they can do some really cool things really, really fast, even if they have no idea that they're doing it. Next question.
Okay, the next question is from Michael. He asks, when Alexa sees that I tell her to wake me up at 6:30 3 days in a row, and then asks me if I want to get up every day at that time, is that AI? When she recognizes my voice and calls me by name, is that AI?
Yes, you will see that natural language processing, chatbots, all this is part of, Alexa asking you questions and you answering, you are feeding the software information about yourself, and you're getting that bot to work better to serve you. Yes, that's all part. Alexa, Google Home, Siri, this is all part of it.
That's all the questions we have for now, but we encourage you to continue to use the chat box for any questions you may have.
Okay, so, and I'm going to pick up the pace, and if I get dizzying, just say, yo, Pursell, calm down. All right? AI is just math. That's all it is. It's just software working on hardware. Computer architecture hasn't changed since designed by John Neumann in the 1940s and 50s. That's not different. Software is a bunch of ones and zeros. AI has nearly nothing to do with human cognition or neurobiology. And that's just not me. We're talking like the gurus of AI who put this stuff together, say, we have neural networks and neurons. And they say, unfortunately, people have kind of taken those comparisons and run away with it. A neuron does so much more. It's kind of mysterious the way it's a biological entity and it lives, and it's so much more complicated than simple switches and ones and zeros. It really, and can anyone reduce human cognition to math? If you can, great. But look, if this is math, it's great. The math is terrific, and the code makes it easy. Now I'm going to start whizzing through the math, and your eyes are going to cross probably. And I'm just going to reassure you how easy the code and the software libraries makes this. All right, here, boom. These are the 5 things that AI can do. There's no denying this. Predictive analytics, you could also call it data mining. That include descriptive analytics, diagnostic analytics, taking like all these data inputs and then helping to decide, is it a this or a that? Given all this, based on the training, on the known outcomes, will it be a this or a that? Predictive analytics. Image recognition. You take digitized photos, break them down into vectors, streams of numbers. And if you train up an AI algorithm, yeah, it can say what's in the picture. It really can. Natural language processing. If you take every word and every key strike and turn it into numbers and use AI, and you get enough of these things called parameters, my God, we have these things now. They can translate an entire book, one file, from English like to French or from English to Spanish. It's going to make mistakes. It needs to be reviewed, but it doesn't do all that bad of a job. It's really kind of something else. Data transfer. It can find, if you tell it what to do, it can find data over here in this format, in these files, in these places, and it can move it over there and do this to it. That gets us into RPA, robotic processing automation, all that kind of good stuff. And then content generation. Yes, it can produce photos, digitized photos. It can produce sound files. It can produce text based on zillions of examples. That's why we have these things called deep fakes. There's a lot of pictures of people out there who never existed because a computer made them up. Content generation, visual, audio, and text. All right, don't go crazy on me. This, at the heart of AI, is the neural network. And all it is a bunch of data inputs. They're all numbers. And here's the key thing behind it. Every single data input, it could be as long as 10, as short as 10, or as long as a couple 100 million. See all these lines? There are these things called hidden layers. In the hidden layer, just imagine each of these round things is a function. You take all these numbers and they all go into these functions here. And at the end of these functions, they produce another number. And then they get loaded into the next layer where all the numbers that come out of this layer go into each one of these things. And you just do a bit of multiplication on all of them and a little bit of addition. And then, a touch of calculus. And then boom, you get your final output. And they can have different shapes. And every one of these circles is just a function. That's all it is, of taking numbers in and doing things with them and moving them around. That's really all it is. Now, here, I'll just give you an example. All right. All the inputs, these are a bunch of numbers from X to the 1 to X to the N. Could be a million, could be 10 million, could be 100 million, could be 2. Each one of these numbers gets another number called a weight. They are multiplied together and you add up the whole schlemiel and you add a little number, just one, called the bias. Then it comes up with this number we call Y, and you try to get all of these numbers to come out to answer your question. Is it a 0 or a 1? Is it a this or a that? Is this person going to click on it or not? Is this person going to pay back the loan or not? And there's a couple of functions that you can use, like the sigmoid and the ReLU. All I want you to see in the sigmoid, it can go negative to infinity, it can go positive to infinity, but the sigmoid function basically forces all the negatives to be 0 and all the positives to be 1. So you get all these numbers come out here and you try to push them into different categories. That's all this is. This is the same thing written up here. All of your inputs, multiplied by weights, added up, added a bias, little function to determine your outcome. That's all it is. Now, here's the totally cool thing. This is so cool. When I was learning about AI, when I saw this, I was like, wow, this is neat. Here's what it does. Backpropagation. To me, this divides. There's so much fake AI, it isn't even funny. People say, yeah, we have artificial intelligence. Then when you look under the hood of their code and their algorithms, there's no backpropagation. Backpropagation does this. We have the forward feeding going on. Yeah, you get all your inputs and you multiply them by weights and you add your bias and then you put it through the transfer function, get it into 0 or 1. Well, backpropagation says, okay, you came up with a this. Well, we're training this system. It should have been, based on our labeled data, it shouldn't have been a 0, it should have been a 1. So then backpropagation looks at the difference between the actual outcome and the outcome that it should have been. And then it goes back and it makes little adjustments to the bias, little adjustments to each one of these weights, each one, millions of them, hundreds of millions of them, billions of them. We're up to machines now with 1 trillion plus. And it makes little adjustments until the machine then runs it forward again and gets it right. It's called backpropagation. And this is really difficult calculus. They use derivatives to do this, derivatives of differences, and all the rest of this. All I want you to know is this, that the frameworks for, the frameworks for this thing called deep learning, it's AI, it's a certain kind of algorithm. You can do this with 1 line of code. 1 line of code will do all this math, this welter of derivatives and measuring to set off that process of going backwards, getting the weights and the biases, the parameters, the little numbers reset so that you get the right answer. It doesn't work at one go. You measure it. Say you're up here, and this is a graph, and what you measure is the slope of it. And you want the slope as close to 0 as possible. What you're doing is you're measuring the difference from the outcome from how you want it to be. Again, don't freak out from the math. The software libraries do it for you. What you want to do is you want to get the system as accurate as possible with little nudges. It runs back and forth and back and forth and back and forth and back and forth and back and forth, millions and millions and millions of times. And you can sometimes graph these things in 3D and they kind of meander around. But the point is, you want the slope of the gradient of your, well, it's called the loss function, as close to 0 as possible. You want the minimum error. We're talking about error. You just run these things a zillion times. You want to get as accurate as possible. It means minimize the error. This is the math, and it's done with a line of code. People talk about AI having a black box that you can't tell why it makes the decisions it does, which is totally true. Because when you tell the computer, okay, spit out the weights, this is what you get. Here's the biases and the weights. And this is a joke AI algorithm with 20 weights and 2 biases that happen to be 0. What are you going to do? Why didn't I get my loan? Open up the algorithm and tell you why? You would just get a spit out of these numbers. Imagine hundreds of thousands, millions, billions, even 1 trillion of them. You can't tell. You don't know why it made the determination it did. Now, you can test the algorithm. There's something called sensitivity analysis. You can play around with it. You can take and they do this with, especially things that concern people. It's called, you take an input and you jazz it up. Say you care about biases against race and gender in hiring. You can take your data set, you can take all your data and you put it in and you boost the weights for gender. And you can see how it influences the outcome. You can take all your inputs and you boost the weights for race, or you can lower them. And you can see if it made a difference in the outcome. You dink with it, you play with it. You'll never get a straight answer, but you can tell which inputs are more important than others. Now with people and personal data, you can do more of this, but when it comes to a picture, let me give you an example. The US military set up this system, and the US military is pouring billions into this. They set up this system to look for tanks and images of the sides of forest. At the edge of a forest, difficult place to hide a tank. Hide it in the trees. And stick out, you know, the big cannon thing. All right? So they poured in all these pictures and they thought they got it. And then they got the cost function down really low based on the training set. And they put it in the field and it didn't work at all. And they figured something out. Oh, too many of the pictures had a blue sky. When the weather was gray, it threw out the algorithm. Someone else set up this fantastic system for picking out wolves in photographs and in video. They wanted to find the wolves. The problem is that they trained the algorithm just on photos and had a lot of snow. So when they put it into practice, the thing worked great in winter, and it was a disaster when there was no snow. Like, what's the problem? They figured out too much of the training set had snow. The algorithm was saying, if there's snow, there's going to be a wolf. The thing doesn't know what it's doing. So really quickly, there's different shapes for these things. Yeah, okay, you feed forward, but in this one, your output comes back again. This is a way you keep like word meanings, the recurrent neural network. I'm not even going to dwell on these things. Here's this awful named one, the long short-term memory neural network. Okay, this thing, again, also you feed things in and the outcome comes back around to be met by a new input over here, and they have different output gates. It's just math, folks. It's just people taking this output and sticking in there, making it go around again. But these structures really help with natural language processing. Or if you're trying to get the translation of the later words in the sentence right, you need to remember the words that came earlier in the sentence. So you can do that by having those same numbers come around again. This thing is totally cool. The convolutional neural network. You get all these numbers, say pixels in a picture, like piles of them, and you arrange them in a big matrix. Computers can do this. You take a kernel function, this gets into linear algebra, and this kernel thing like runs over all the numbers and produces an output of totally different numbers. What it does, it changes the numbers. They call it citing features. This thing really helps to identify images. Here's a big block of numbers, and they run the kernel functions over to produce another block, another matrix of numbers. And these matrices in computers can actually seem like they have 3D. You just run it through this and run it through that, and then put it through this sorting layer and that, well, they're called fully connected layers. You do all this and they can get really good at saying what's in a picture. It's just math. Brilliant, wildly complicated, structured math performed by software. I have a video to show this to you in action, but I'm running out of time. So maybe people really want the video, and it's a really kind of cool thing. We can come back to it, but not now. To wind up, because this is going everywhere, because whenever you do anything on social media, whenever you order anything, whenever you look for anything, everyone's had that experience. You look for something, oh, and then an ad pops up. Everyone's had that experience. It's AI, and it's working on you. We at DeSales are trying to prepare our students for the present and future workforce. In the undergrad, we have a full data science track in the computer science major. We have majors in accounting, business administration, finance, marketing management, supply chain management, health security, and nursing, with tracks in data analytics and applied AI. AI is just data analytics. That's all it is. And at DeSales, we do not do algorithmic research. We do not do robotics. We are not trying to compete with MIT and Google. They get endowments. People have given them billions as gifts to look into this stuff. We want to train our students to know the algorithms and the tools so that they can work in organizations that have an AI strategy and they can add value. For lifetime learners, there's stackable certificates. And at the graduate level, we have a Master's of Science in Data Analytics. We have an MBA track in Data Analytics, nursing MIS as well. We have stackable certificates in nursing informatics. Folks, we are living in a digital age. This is the evidence. We need to use evidence to help organizations to make predictions, and we need to use AI to help people in their work to automate the things that only take half their brain so that they can really solve true problems the way a human being only can. Floor's open.
Hey, Dr. Pursell, we have a question on Facebook. So we're also live on Facebook here. We have people tuning in there. The question is, will China be the leading AI superpower in the years to come? If so, how will that impact the USA in general?
Great question. Huge question. This question's on fire. China's been pouring billions into this. So is now the United States. There's a huge difference. One is China is a dictatorship, essentially by one party. There is no such thing as privacy. So China can do anything with anybody's data. And also in China, there's it's a centralized system. They can have total surveillance over everything, and you are powerless to stop it. Powerless. So they are leading it. They really are, in sense of deploying it on populations. I don't think we're ever going to do that. We're the United States. We don't like that. We like individual freedom. We really do. It's hard to get data, especially when certain companies have it. Our federal government shares data. Go to data.gov. Every agency shares its data. China shared data. Are you kidding? Talk about cooking data, cooking books. I wouldn't trust anything that came out of China. I'm sorry, that's just me. I don't want to sound like a jingoistic person, but I'm sorry, I'm a citizen of the United States. That's a problem. However, we got the smarts. They got a lot of smarts, but we have to have a nexus of private companies and public interest. And I'm terrified that most of the people in Washington don't know any of the things that I just told you about. I'm really scared that the 70 and 80-year-olds who run the country in those committees, that they really don't know what it can do, what it can't. So the military is pouring tens of billions into general awareness AI. What the heck is general awareness? You got me. But the military has a long history of pouring billions into projects that don't quite pan out. Is that a satisfactory answer?
Yes, thank you.
I mean, it's going to be a big deal. It's getting into the military. It's everywhere. As the world digitizes and the internet's everywhere, these are the tools.
We have a question from President Jim Greenfield, Father Green Jim Greenfield. He says, your thoughts on IA helping with supply chain for the vaccines right now?
Okay, so just when COVID came out, the bubbly little company saying AI will find a solution. Guess what? It hasn't. AI has contributed nothing to the development of vaccines. It's just too complicated. It's too complicated. However, AI tools are really good at sorting through all the research. Those databases were set up to help researchers go through all the data in the research. Your question was about supply chain and logistics. Yeah, I hope they're using this. These heavily refrigerated deep freeze units, they have GPS on them, they're tracked. Man, the logistical challenge of vaccinating the whole country is enormous, and I hope they have the best in class. I don't know which companies are doing this. I really don't know, but I hope they have the best in class that are using IoT data, the Internet of Things. And I wish they would build a database of it. There should be a central database. You put it in blockchain and you ID everybody. But people don't like, in our country, they don't like being in central databases. I'm afraid that's not happening. But anyway, yes, it's being used in logistics and supply chain, yes.
Okay, we have another question from Joe Parker. What role do you see AI having on education, especially not now that COVID has forced many students and teachers online?
Okay, the dream of AI is to have the personal tutor. And there's a really cool company in Sweden called Sana Labs. And what they're trying to do is working with a couple of schools and school districts and academic publishers to say, get students to build a personal data repository of everything they do online. We have all sorts of educational apps. Imagine if we got all that data in a good analyzable format so that your track record of making mistakes about this and that and this and that are enough so that you get flagged and so that your personal tutor can say, you need to work on this more. So let's feed you more of these things until your score starts going up. Stuff like that. But in education, oh my God, now, yeah, you can buy papers made by algorithms. Yeah, they're not very good, but you just put in the parameters and the questions and the word length and the number of citations you're supposed to do, and algorithms can kind of do this for cheap. The capacity for cheating is incredible. It's not smart. AI is not smart. Teachers will always need to be there, but the tools are there. And I hope some good will come. In language teaching, I'm sorry, but AI, natural language processing, is getting so good at translating languages. I mean, so good. I really wish at DeSales and at other places, a language requirement would be satisfied by learning Python and SQL. These are computer languages. These are highly useful. And my God, you know, we have now hearing aids that attach to your phone. And when someone's talking to you in Spanish with a little time delay and a decent internet connection, you hear the full translation. And it's not that bad. It's getting better all the time.
We have another question from Chris. When my computer does something I did not tell it to do, is that an example of AI?
Okay, I love the question. Thank you. I know a computer engineer who lives nearby, and I was frustrated saying, "Oh my God, do this in the computer." And he looked and said, "Brennan, computers do exactly what you tell them to do, and nothing else. If your computer is screwing up from something you put in, it's because of you." I didn't want to hear that. Software does run into problems, but if your computer crashes, I'd like to think that's not because of AI. Computers are wildly complicated. They're amazing, but boy, they're complicated. And there's all these different layers of software, and things can mess up. The AI to be scared of are those tools used by cyber criminals. They're called autonomous weapons. And they go cruising and crawling about the internet, looking for open ports. And they just run in all kinds of, you know, different passwords and different things. So where they find a hole, they just start doing their thing. And then the cyber criminal who's in Tehran or Pyongyang or Moscow or Bethlehem, wherever, they're all over the place. They're domestic, they're international. They get the little warning, I'm in, I got a dummy.
Larry asks, what is the best use of AI for the development of the future management of DeSales?
Well, for the development of the future of management, you mean managing DeSales or the program in management? I think you mean management of any organization. Any organization needs to think about its data. Where's your data? Are you even keeping your data? Is your data organized? Can you consolidate it? Can you build? Sorry, oh, that hurt. Can you build a platform? Can you build a platform, and can you consolidate your data? You have to get some data wranglers. You need a data team to look at the data about your key constituents, your customers, your students. There's a lot we could do, but at the same time, we're small. But organizations that do best with AI serve millions, tens of millions, hundreds of millions. You need lots of data to train AI to do anything because it doesn't know what it's doing. You know, a few thousand people, you can't, there's plenty of other algorithms, good predictive analytic algorithms that don't need the masses of data that AI does. So I think DeSales should look at it, but have it really be just an aspect of a coherent strategy about data management and getting your platform secure and cost-effective and reliable.
We have a question from Alan. He says, where do you stand on whether the folks creating and generating insights with AI should be required to disclose the why behind the output and decision an AI produces?
Where am I on this? I love the idea. I'm afraid it cannot happen in practice. In Europe, in the European Union, they passed the GDPR, the General Data Protection Regulation. And in it, every European Union citizen has the legal right to know why. If I'm rejected, if this algorithm won't open an account for me, tell me why. I think to this day, it has not been challenged in court. And I'm sure engineers and people tell you, well, you can ask and we can't tell you. What do you want us to do? Look at 75 million parameters, little tiny numbers? That's not going to tell you anything. I mean, we could do sensitivity analysis, but your case is a vector. Your case is a string of numbers that went into a computer that had a lot of weights attached to them and a bias added to it. And it went bumbling through different layers, and we didn't train on it. Your decision was an output. But every firm that uses this needs a form of redress. There has to be a human element because the disasters are well documented. AI doesn't know when it's screwing up. It doesn't know. Someone put together this big thing up in Idaho, this automatic AI thing about putting people onto disability and managing their benefits. And the system started throwing out all these people with disabilities, with a handicap. And they're like, what the heck is this? And they look at it and, oh, the data set was a disaster. No one had worked through the data set. It was loaded with nulls. There were duplicates. The columns didn't make sense. Garbage in, garbage out.
Dr. Joe Colosi asks, can a machine ever become self-aware?
Oh, dude. If it does, or if it's pretending to, I'd unplug it. I'm sorry, Joe. That's a huge question. I don't think so. I think the human being is a living miracle or a biological event, and we're part of history, and we're totally amazing. And I don't think we've been engineered. We happen. We're amazing. You know about 1 billion times more than I do about that. But a machine becoming self-aware? Yes, there's arguments for machines knowing things. Yeah, you can engineer it different ways, but you know that little blinking cursor? There's only one question a computer asks. What should I do next? Blink, 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 blink. What should I do next? If you call that self-awareness, fine. Sorry, that's a non-answer.
I don't know if we have any other questions here today. Again, we ask that you use the chat box.
We do have a follow-up question on our Facebook question. It says, if China operates outside our USA ethical boundaries, then it is safe to assume that they will be #1 in the hierarchy chart.
In the which chart?
Hierarchy.
Okay, if you're saying China cheats, that the Chinese government cheats on things, look, I'm sorry, I sound like a historian. The history of the world is rival empires. It just is. And they will kind of do anything to stay alive and to grow as they can. In the United States, we have our own ethical problems with AI, and I think we could do a lot more. Google these days has appointed these very high-ranking female ethical scholars, and they're quitting one after another because they find these problems, and they say, we need to solve this, and then they're told that nothing's going to change in the giant Google cache machine, and they leave. They get frustrated, and they quit. What Facebook gets away with, it's just incredible. I personally think we would do better if we put our own AI house in order. But in terms of China becoming #1, I don't know. I can't predict history. But they'll do just about anything they can to keep us from stopping them from what they want to do.
We have another one in the chat box. Chris asks, is software to diagnose illnesses in AI?
Yes. And get this, IBM's Watson. This was the famous AI that won a couple of games, chess, things like that. IBM Watson quietly is scaling back its health app. There's notorious examples. What was it? It was IBM Watson, I think, with the big cancer center. Was it M. Anderson? They spent like $50 billion on the system to diagnose and treat cancer. They didn't treat one person. So health apps, diagnosing, I'm sorry, that's just kind of, that's pie in the sky. But there's so much we can do with health records and predictive analytics, but there's HIPAA and there's the whole regulatory environment really tough. Most medical records are still stuck using fax machines. The fax machines, when they send stuff, it comes across as unstructured data. You can't take that data and just transfer it into another database. And of course, hospitals and healthcare systems are not necessarily thrilled to share each other's data. They've done pretty well with image recognition. There are some app companies where it's like you scan your own body and the machine tells you, is this thing a melanoma? What chance is it that this is a melanoma or not? Automate the annual scans. Do it on a cloud solution. Do it from home. Do it with your phone. Those things are doing really well. Radiology, saying what's going on in X-rays, that's tougher. If the angle's off a bit, it's, you know. Sometimes they get some success, but it's hard to replicate.
Matt asks, if the algorithms are created by humans and the data collection systems are designed by humans, why the word artificial?
Okay, great question. Thank you. Artificial intelligence was developed by this guy in the 50s. Artificial intelligence. He did it in a grant application to get money, to get some engineers together to come up with a computer that could learn, to take its outputs, to improve its processes. Why is it called artificial? I think artificial was a really trendy word then. Artificial this, artificial that, artificial coloring, artificial flavor. 50s, why is it called artificial? We're kind of stuck with it. It's data analytics. That's what it is.
Kathleen asks, how would AI change or affect the future historians' study and interpretation of history?
Ooh, well, there are some really cool algorithms. I mean, history, of course, will be funded the least. So there's not many out there, but there are some really cool projects where all these archives have miles and miles of papers written by hand. Well, there's AI algorithms you can train in that paleography, in those old scripts, and just scan the things in, then they get digitized. And then you can run natural language processing algorithms on it. There's all kinds of neat things happening with that. But as everything becomes digitized, as the cost of storing the data continues to plummet, huge cloud providers, I think, Kathleen, that history should be done. Moving forward, history of the 21st century should be just using digital tools. Scroll, for my dissertation and for my first books, crawling through old archives and looking at the old dusty papers signed by kings. That was cool. Not doing that. No, that's now irrelevant. To the 21st century, done.
We have a question from John. Does AI challenge the very premise of a liberal education in that it affirms and furthers what a person already knows and likes, yet it prevents him or her from being exposed to other disciplines and knowledge?
That would be a tragedy. And I think the most important aspect of your question is that, yes, we need to train everybody on what this is so that they know what is happening behind the recommendation machines. And so they realize that the machine does not have agency unless you give it to it. The machine does not know you better than it does than you do yourself, unless we are willfully blind to ourselves. The algorithms are amazing and the data is really big, but we decide to a certain extent who we are, what we say, what we think, and what we do. And people use AI. AI uses people, but if people ever turn their free will, can I wax Catholic? If they turn their free will over to the machine, then they have done so. I think there's a wish. I think there's like a timeless wish for the perfect servant. Think of Iron Man and Jarvis, Friday. There's this dream to have the servant that not only knows you and does everything you want, but who anticipates your every need. And that's what Google Home is trying to do. And Alexa, hey, I think you're in the pizza. You're in the meat for pizza tonight. I see what your schedule is, and I know that you haven't budged. And I know that on your TV, you've watched 7 football games. You always order pizza when it's 11 p.m. How about a pizza from your favorite place? Yeah, algorithms will do that. And if that's the life we choose, that's the life we choose. But liberal education has got to be more. If this renders it irrelevant, then we failed humanity.
We have our last question from Lisa, and she says, how can we minimize bias, protected classes in AI?
Okay, this is really hard. Really hard because the data sets they put together are overwhelmingly lighter skinned than male. They just are. Facial recognition systems do poorer with people with darker skin. There's no reason for this. They are actually using, there's some brilliant things going on. They're using AI content generation. There's an algorithm called GANs, a generative adversarial network, and they're producing pictures. They're taking pictures of all kinds of people in the majority, and they're adding minority elements in order to produce more pictures that no one has taken. They're fake, but they're kind of good enough maybe to help balance the data sets. Yeah, that's a huge problem. However, they're also getting better with sensitivity analysis. Microsoft, Google, Amazon, they're making it so easy to set up these predictive analytics systems for a business, and then to give you some controls. It shows you your outcome accuracy. But if you want to alter your gender breakdown of your output, you can do it. If you want to alter, the racial breakdown, the profiling of what your decisions are, you can do it. It's a big problem, and people need to talk about it. People need to be upfront about it, because it's just data. The AI doesn't know it's being biased. And the bias is a generalization we find distasteful.
I think that is all the questions we have today.
Thank you, everybody. This was really stimulating. I'm so sad I couldn't see all of you, but we made it. We made it. And anyway, I wish you a very good lunch, and you will please excuse me. I really need to go lie down now. That's exactly where I belong. So signing off. Take care. And everyone, please come back for these. Come back for more. This is what we want to do with DeSales, the Virtual Scholars Series. Show you like our value add to everyone in the DeSales community forever. Okay. Thank you. Bye.
Dr. Pursell, thank you so much. Yes, he is hurting, and you wouldn't have known it if he didn't tell you. So that was awesome of him. Thank you all so much. Hey, so if anyone wants to watch this again, slow down those slides, maybe take a quicker look. You can watch it again. It's been recorded. Visit desales.edu/alumni, and we're going to upload it there. We also want to tell you about ScholarSeries coming up. The dates are going to come up on screen. We've got one on patents, a patent panel that should be very interesting. We've got alums, experts in their field for that. We've got a coronavirus and the vaccine experts coming up in April to share that, some faculty members. We've got information about terrorism, violent extremist recruitment. That's in May. These will continue to happen. There are so many wonderful faculty and staff here that have so much to share. So we'll keep emailing all of you with this information. We hope you'll join us for many more of these Scholar Series events to come. So I think that's everything. Jackie, Dan, anything else we want to share with our audience?
No, just thank you so much, Dr. Pursell. We enjoyed having you today, and we look forward to seeing all of you at our next event. Have a great day.
Great day, everyone. Thanks.